In this video, we will be discussing about various soil parameters and also about their limits. So let's get started. So here you can see I have constructed a diagram of the soil sample. Okay, so this thing that is the brown region which is hashed is representing our soil solids. Okay, and the blue hashed region is representing our water present in our soil sample. Okay, and the blank region which is present in our soil sample is nothing but air. Okay, and you must also remember that these only two combinedly are present in voids. Okay, in our voids air and water are only present. Okay, so this is basically a partially saturated system, or you can say a three-phase system. Okay, this can also be represented as a three-phase. Okay, three-phase. Okay, so let's talk about the very first soil parameter, that is water content. So water content, I represent water content by the symbol W. Okay, I represent the water content by the symbol W. So water content is nothing but weight of water upon weight of soil solids. Okay, so what I have done here is I have measured, or you can say I have weighed all the moisture present in my soil sample in the numerator, and in the denominator what I have done is I have put all the combined weight of soil solid particles, okay, in the denominator. Okay, so this represents my water content. So this is the very first formula of water content. Okay, so now let's talk about the limits. So if I ask you, can my water content be equal to 0? So when will be my water content equal to 0? When my weight of water will be equal to 0. And yes, that can happen in case of dry soils. We know that in case of dry soils all the moisture will be absent. Okay, so my weight of water will become 0. If my numerator is a 0 value, then it means that the whole value of this fraction, or you can say the value of water content, will become 0. So yes, we can have a 0 value of water content. Okay, if I talk about can my water content be equal to 1? So when will be my water content equal to 1? If my weight of water is equals to weight of soil solids. That is, if my numerator and my denominator will be equal, the both thing will be cancelled out and I will be getting water content as 1. Okay, so I can also have a 1 value because this thing is also possible. Okay, and also, can my water content be greater than 1? When will be my water content greater than 1? If my numerator, that is weight of water, will be greater than weight of soil solids, and that can also happen. Okay, so this is also possible, this thing is also right. So I have my limits as that water content can be greater than equal to, you can say, 0. Okay, so it has no upper limit. Okay, it has no upper limit. Also it can be equal to 0. So these are my limits. Okay, now let's talk about the second parameter, that is void ratio. Void ratio, I represent void ratio by small e. The formula is E is equals to volume of void upon volume of soil solids. Okay, this is the main formula of void ratio. Now let's talk about the limits again. So can I have E equal to 0? Can I have E equal to 0? When we will be getting E is equals to 0? We will be getting E is equals to 0 if my volume of void is equals to 0. And imagine if I suck out all the empty space from this sample, or all the empty space in this sample is absent, wouldn't this sample become solid? Okay, so if my if my volume of void is 0, I will have, I can say that soil will not exist. Okay, it will become a solid. Soil will not exist. So the main thing, which is soil, which is our domain in this subject, will not exist. So this case is not possible. E cannot be equal to 0. Now if I talk about, can E be equal to 1? E will be equal to 1 if I have volume of void equal to volume of soil solids. And yes, that can happen. Okay, that can happen. So this thing is right. Can E be greater than 1? I will be having E greater than 1 if my volume of void is greater than my volume of solid. And yes, this can also happen. Okay, this can also happen, that my volume of void is greater than my volume of soil solid. So my limits are that E can be greater than 0, and we have no upper limit. Okay, no upper limit. Okay, in previous case of water content also we were having no upper limit, but in water content we were having that water content can also have a 0 value. So that's why we had put a sign greater than equal to there. But in this case we cannot have E is equals to 0 condition. Okay, I hope this thing is clear. Now let's talk about the third parameter, that is porosity. Okay, so porosity is represented by the symbol eta. Okay, so porosity is nothing but eta is equals to volume of void upon volume of total soil sample. Okay, if I want to get my value in percentage, I can always multiply the parameter with 100. Okay, so volume of void upon total volume of soil sample will give my porosity. So again, if I take all this volume of my soil sample, for example, this length, let's assume this is a cubic sample. So if this length is L, okay, if this length is L, so L cube, so L cube will be my total volume of soil sample. So L cube will come over here, and if I somehow calculate the volume of voids and I divide the both, okay, I get the ratio, I find the ratio of both. Okay, I will be getting the porosity value. Okay, so now let's talk about the main thing, that are the limits. So again, can my porosity be equal to 0? When will be my porosity equal to 0? If my numerator is equals to 0, and in numerator I am having volume of voids. So can my volume of voids be equal to 0? No. If my volume of voids is 0, my soil no more exists. Okay, so this case is not possible. Can I have eta is equals to 1? So when will I have eta is equals to 1? When numerator and denominator both will be equal. So if my volume of void is equals to total volume of soil sample, now look here, my total volume of soil sample is nothing but volume of void plus volume of soil solids. Okay, what you can observe here is that this thing on the LHS I am having the same thing, that is volume of voids, and on the RHS also I am having the same thing, that is volume of voids. Okay, now to the RHS I am having some term that is adding over here. So we will always obtain my RHS, or we can say that always my RHS will be greater than my LHS, because I am adding something to this term VV. Okay, so we will be having this case, RHS will be always greater than my LHS. So also this case is not possible. Now let's talk about the third case. Can my porosity be greater than 1? Now when will be my porosity greater than 1? If my volume of void is greater than total volume of soil sample. And can this happen? This cannot happen because my volume of soil is nothing but volume of void plus volume of solid. and RHS, that is volume of void plus volume of solids,
cannot ever be smaller than
my volume of voids. So this case is also not possible. So let's just finally frame our limits. So our limits become eta can have a value greater than 0 and cannot have a value greater than 1. Okay, so these are the limits. Now let's talk about the fourth parameter, that is saturation. So I represent my saturation by the symbol S, capital S. So saturation is nothing but volume of water upon volume of voids. Okay, so this is the main formula of saturation, volume of water upon volume of voids. Now let's again talk about the limits. Can my saturation have a zero value? Can my saturation have a zero value? So my saturation will be having a zero value if my numerator will be equal to 0. So can I have my volume of water is equals to 0? Yes, this can happen in case of dry soils. Okay, in case of dry soils this can happen, this condition can happen. So this thing is true. So can I have saturation is equals to 1? So this means that my volume of water, that is my numerator, will be equal to my denominator, that is volume of voids. So this can also happen, this can also happen, no issue. So this is also correct. Now third thing, can my saturation have a value greater than 1, or if I am talking in terms of percentage, so can my saturation have a value greater than 100%? Okay, so can my saturation have a value greater than 1 or 100%? So when will this happen? If my volume of water is greater than my volume of voids. Okay, so is this thing possible? I know that volume of voids is nothing but volume of water plus volume of air. Okay, even if I take the cases of dry soil, okay, even if I take the case of dry soil, this volume of air will become 0. Okay, and on the LHS I will be having volume of water only. So even in this case both the terms will be equal only. Okay, and if I talk about the simpler case in which I will be having my volume of air present, so my RHS will be always be greater than my LHS because something is adding. Okay, so this condition is not possible, that is saturation cannot be greater than 1, or you can say 100%. So let's frame our limits. So I can frame my limits as that my saturation can be greater than equal to 0 and should be less than equal to 100%. This is in terms of percentage. If I talk in the terms of numerics, I will be having my saturation can be greater than equal to 0 or can be less than equal to 1. Okay, so this is all about saturation. Now let's talk about the fifth parameter, that is air content. Okay, so air content, I represent air content by the symbol small a and in subscript I write C. Okay, so this is air content. So air content is nothing but volume of air. It is just like saturation. So volume of air upon volume of voids. Okay, so how much air is present in my volume of voids? So this is air content. So this is the main formula of air content. Now if I again talk about the limits, so this will be the same case like our previous one. So can my AC be equal to 0? So when will be my AC equal to 0? If my numerator will be equal to 0. So can I have such a case in soil that my volume of air becomes 0? So yes, I can have in case of saturated soils. Okay, so in case of saturated soil, that is if my soil is completely filled with water. Okay, or I can say that if my soil is having only water as a constituent in its voids, I will be having saturated soil. Okay, so yes, this case is possible, that is AC can be equal to 0. Now can AC be equal to 1? Okay, AC will be equal to 1 if my volume of air will be equal to volume of void. So this thing can also happen. Okay, so no issues. And the third thing is, can I have AC greater than 1? So AC greater than 1 means that my volume of air will have to be greater than my volume of voids, and this cannot happen. Okay, so this thing will be excluded from our limits. So let's write our limits. So AC can be greater than equal to 0 and should be less than equal to 1. Or if I to take the case of the percentage, so 0% to 100%. Okay, so this is quite similar to our previous case, that was the case of saturation. Okay.